is Team Forge, and this is our project for the hackathon. So we have basically selected the fourth problem statement, which is multi-layer summarization of a long text, which is given in a PDF format. So this is the repository of our project, and here we have added the most important instruction that we have used Google Colab because of GPU limitations. So we have added the paths in our source code according to the Google Colab format. And here this is our full source code opened in the Google Colab. So this is our importing shell, and this is the main shell which calls the Llama 3 latest model and activates it in the backend so that we don't have to use any API key for online learning models and all. This works on a local basis and calls the model in the backend and get the responses. And here we are beginning with the functions. So first one is to load the PDF, and then this one converts it into a readable text. And then we have this one for docx type of files. And finally, we are doing chunking of the source document into various chunks and split, and then we are doing it in a level wise order in a hierarchical way so that we can summarize step by step. So the first thing we are doing is splitting the document into chunks, and then we are splitting it into paragraphs, and then finally into sections, and then chapters. So this is the complete hierarchy of our summarization. And finally, we are creating all those things and mentioning the page number so that we can trace back to the original document, which was a requirement of the project, that we should be able to find out which part of the summary is from which location of the original text. So that was it. And here we have extracting function for the chunks. And finally, we have this main function which gives the prompt to the Llama model and takes its response in the backend in a local level, not using any API. So this is for different levels. This one is for section, and the above one was for paragraphs, and this is for chapter. We have created a well-structured prompt so that the model doesn't hallucinate and gives the response only on the provided context. And finally, we have this contradiction detector, which was a requirement according to the project description. And here we have traceability manager, which is the most important part of this project, which basically traces back to the original document's location. And here we have explainability engine, in which this format report text function creates a human readable report format which non-technical users can easily read and understand. And finally, this is the main execution cell, which calls all the functions in a structured and a pipeline manner. And here we are using the collab, so we have added the paths according to the collab. If the evaluators are running it on VS Code or any local machine, then they have to edit this path accordingly. And if this shell gives error related to Llama, then this cell right here needs to be executed again. This one, because many times there are connectivity issues from Llama's side. So this cell, when executed again, will solve the issue. And after that, if we run this one again, we will just get these chunks separated, and then we can make a classification report and output everything that we have got. So the output right here in the shell is not very readable and understandable. So we have created a UI using Streamlit for that, so that we can easily understand. So the user can easily understand what is the result of all these summarizations and all. For that, we have to basically save all our progress from here using this part of the code, and this one is to create a zip file, and then we will be downloading that zip file and pasting it in VS Code. So from here we will be downloading basically these two main folders that in which we have all the progresses, and after downloading it in this zip format or anything that we like, we will paste those folders in the exact same location where this app.py is. So this is our app at app.py, which uses Streamlit to create a web page, which is more explainable than this shell, which gives the raw output like this. This is not very easy to understand. So to run this, to get the web page, we have to run this command streamlit run app.py, and first we have to ensure that we are in the correct directory. After running, our web page will open. So basically this is the original document which we are referring to here. This was of 33 pages, and we have summarized it and into smaller part, level by level, as expected from the project description. This is the user interface. Basically it tells us the pages and all the statistics, counts and all those things. And finally on the first tab we have the final summary of the document, which is very small as compared to the original document, but still it's capable of answering most of the questions. It is a complete text and a complete information in itself, so we can basically get information based on this as well. We don't have to go through the entire original document to answer simple questions. And this is the summarization hierarchy, which is first we get a chapter wise summary, and then we have section wise summaries. In this document we have, our code has created 3 sections, and here we are able to see the summary for each section, and on the top of it there is a summary for the entire chapter. So this is the basically hierarchy which we are following. And finally we have the paragraph based summary, which creates the small summary for each and every paragraph. And here we have implemented the traceability as well, which is basically in each of this drop down we have in each of this drop down we have two things. One is the compressed version, the smaller version of the original text, and here we have the original text to refer from. And this can basically be used to verify that our LLM is not hallucinating and giving wrong responses. So this system allows us to uh, take a glimpse of the original document so that we can verify from our side as well whenever needed. And here we have the information about where exactly in the original file this information is located. So we have the same traceability for all the summaries as shown here. For all the paragraph we can trace back to the original document. And finally we have this key factor exceptions and risks, which are basically like uh, main points of the main points extracted from the original document. All of them we can see here in this tab. And finally we have contradiction, which is working fine enough, but we can make even more improvements if there is more time. Basically this in this tab we have two statements which are contradicting each other. And finally we have explainability and all those information that were required as per the report, as per the problem statement. We originally had this many characters, 43,000 something, and we compressed down it to 1269, and we preserved as much information as possible while reducing the size to 97%. And finally here we have also added the machine readable format, which basically used to integrate various parts of the codes together. This is very long and not readable by non-technical users, but this is used in the backend to implement connections between various parts of the code. So this was all about our project. We are basically looking forward to improve it further as well. But because this was a hackathon and the time was limited, we have implemented as much only as much as we could. And for this GPU limitation part, we had to use Google Colab, but we can implement it in our local device as well. But for that, we need a lot of GPU power and time and all those things. Thank you. This was it.